Okay, so let me give you just some examples. I suppose that everything will be clear now. Okay, so here, so how the popen works basically. So I introduced basically the two streams, in and out. So I'm going to basically run two commands, and in this example, okay, I'm going to basically read the output of the first command and then give it to another command. Okay, so here popen, and I'm going to run ls/etc. I'm going to just read the content of the /etc, and then I'm going to read basically the output. Okay, so and I have in. Okay, so this is the file string that I have, and also I'm going to popen and grep m. So remember, okay, so I'm just so I'm trying to just see the output that they have m basically in their name. Okay, and then I'm going to write something, okay, to this string. But for the first string, I'm going to read ls, and I'm going to write to the second one. So in this point, I'm just generating two processes. One of them running ls, reading the content, and also the content I'm going to pass it to the another one. Okay. The first one is executing ls, and the second one is executing grep. But as a first one, just I read the output, and I'm going to basically writing some things, and so this command is grep, but I need to pass something to this command grep. But I'm going to passing basically the output of the first command to the second. Okay. But how I'm going to do that? Okay, so with fread, I'm trying to read, because the size of the buffer here I introduced on is 80. So I said, okay, it's 80 as an input, and then I store it basically in read buff. And after that, I'm going to basically write, because this is the output of the first command. Okay, and then I'm going to pass it to the second one. And so this is the length of the basically buffer here, and as an output. So it means that, okay, so I just run the first command. So it is just for you, it recalls which command?
What?
I mean, this execution, just giving the output of the first command as input to the, yes. So it is just the part that we use it. And finally, just I close through the p close. Okay. Okay. So as you can see, this is the output. But why here? Okay, so this is the output. So I just read from the first one, and then I grep to the one. But one question is that why the list is that much short? Just suppose that if I go to if I ls/etc, and then I type to grep, so the list is just shorter as this one. Because so do you know why the list is? Yes, because the buffer is limited and only just the size of the buffer is 8. But in anyway, so I put for you another type, so you can you can just read the whole content. Okay, so not exactly limiting to the 18. Okay.
But what we are going to do there is the same as doing ls, for example, ls slash.
It's just the same type with
on the same line. Okay.
Yes. It's just recalling the function that the command like ls/etc type grep m. Okay. And then okay, so I go for the pipe. Okay, so this is the one example for using pipe. So I introduced basically the two messages. Okay, C message and also P message. Okay, C message is just I'm saying the child message and parent message. But here I have the, basically this is my first message in pipe. Okay, and the length of this message, basically I put it here, this is 28. Okay, and then okay, so we need to have basically, if you remember, so we need to pass an array with two elements. So fd2, and also I put one end read in order to check okay, how much I read and write from the pipe. But I use pipe. So in this step I create basically pipe. Okay, and after that so here I create by fork, I'm creating one child, and this is the code for the children, right? So basically you need that. Okay, so the pipe, it has two parts, right? One part, as I said, that okay, is one-way communication. So, but basically the pipe, it has two branches for each side. Okay, but because this is a one-way communication, the one part that is just is going to write, so you should close the part that you don't need basically. For example, if I'm going to write, I should close the read part. Okay, and so here, okay, so read is just 0 and write is 1. Okay, std in and std out. And so because the child is going to write some things, so it close basically, first of all, before doing anything, so first of all we need to basically close the fd read. So this is fd0. Okay, and after that we are going to write, but I'm going to write to the, okay, so fd write to this basically descriptor, and so cm basically c message here, and so this is the size of the c message plus 1. So I'm going to say okay, one character as a null character of the string. Okay, so this is the size and this is the message. So I write basically, I'll just print out something. Okay, it's done. I close basically the right part as well. Okay, and from the other part, from the parent part, so first of all, because this part is not just going to write something, so before doing anything you need to close write. Okay, and after that, so I need to allocate the memory with the 28 byte, and I pass it to the message here, because this character star is a type of pointer, so you need to allocate the memory, and after that use that. So I allocate the memory with 28 bytes here, and after that, so I'm going to read from which descriptor. So this is fd read, and then p message, and I'm going to read basically 29 bytes. But why 29 bytes? Because so the size of the message is 28, and also here I plus 1, and so it's basically it's 29. Okay, so 29 I basically wrote to the pipe, and after that printing, and so closing the stuff. And so the something that okay, when I write this code, I expect that okay, child wrote to the pipe, and after that okay, so the other part is just reading from the pipe. But here, because we don't have any control that okay, the parent is the first party, or child is the first part that it basically execute after this fork, because actually after this fork you cannot guarantee that okay, the parent will be executed first or the child will be executed first. It totally depends on the schedule, right? So if the parent is executed first and try to read here, so because the part is empty, waits here with the block till basically the child writes something, and after that so we will unblock and then go. Okay, so as you can see, we have the, okay, this is my first message in the pipe. So let's play a little bit. Yes.
You said that blocking the sense that the parent executes before it waits. But what if in the parent I put read 100? He will wait till...
Okay, so
I don't know how much.
Yes, if you don't know how much. Okay, so first of all, you need to know exactly the something that you are writing to the pipe, and then after that, so you are going to read. You should know exactly, because first of all, the order of writing is the same as the order of reading. Okay, so it's fine. But other thing is that if you are okay, so this is the maximum size that you are going to read. If you don't have that much data there, so you read basically just, for example, if I put, instead of 29, if I put 100, so even that would be okay. You know, here,
And there is a
for example, here, if I just, instead of 29, if I put 100, that would be okay. Because I read, I try to read in one read. I try to read 100 bytes. But I cannot read the fully 100 bytes. I can read, for example, 29 bytes, and that's okay, I'm finished.
So it's blocking just if the buffer is
It's empty. Yes,
It's
it's
not
empty.
empty, and also one character is
Yes. But when it's empty, so there are only two situations that, okay, you will be unblocked. The first situation is that the other party writes something to the pipe, or maybe the situation that the other party just closed the pipe. Even if the other party closed the pipe, so you will be unblocked.
Ah, okay, yeah.
So
So it's possible that.
so for example,
So it's possible that if you open as a parent a pipe and you want to read, and for example the child should write something, if the child closes it, also for the parent this pipe is closed.
close, yes.
Okay.
Yes. But for example, there's something that we are saying here. This is the same example, but I introduced basically here the 100 basically second sleep. I read here 29 bytes, and after that I introduce basically the one more byte. Okay, but here I expect that there is a kind of suspense. Okay, but the reason is that, okay, so I try to read from the pipe even 1 byte, but the pipe is empty, so I cannot do anything till here the 10 seconds pass, and then basically the child close the pipe, and then I will unblock. Okay, so as you can see, just the other party, the parent will be blocked because I'm trying to read till the other part 10 seconds passed, close the pipe, and then I will unblock. So there is only two situations. There is something in the pipe, or the pipe will be closed. But let's see here. Okay, so if I put 100, for example. Okay, so here if I put the instead of 29, I put 100. So basically the situation is the same. Okay. So we pass the first, and then after that 100 seconds. But you should know that the order of the data that you send to the pipe, and also which data you are sending to the pipe. So for this also, I prepared one example for you. Okay, so for example here, I introduced basically one structure here is pipe data. Okay, so in this way I have two types of data. Okay, I'm not dealing with only with one type. Two different types of data exist in the pipe. For example here, pipe underline data, so this is the string. Another one is the same as before, okay, the message. Okay, and so this is the same as before. And okay, so here we have the receive and also send. And for the send we have, okay, Masood 30, Masood 20, and Albert 10. Okay, and then so I try to just set the memory, and here, so the child. Okay, so just check the order. Okay, first of all, I just send the first one, okay, Maktub 30, and then after that, at the middle, I send the text, and after that, another data, okay? So just consider the order, and also at the middle, I inject another type of data. So we have two types of data. And so let's see that what will happen for the other part here. So I try to read. Okay, so the same with the same order exactly. So here reading the message, and after that the rest of it. I'm printing out the data here. Okay, so as you can see, the order is just like this one, okay? And the message is successfully sent, okay? But if I don't know, for example, here, if I don't know, for example, the size of the byte here is just, for example, like 29, if I suppose, okay, it's 28, so in this way I cannot communicate successfully, okay? So because of this, you should exactly know that, okay, so you are sending data, and what is the size of this data you are sending, then another data that you are passing, so how much is the size of that one, so you should have control over this communication. So it's not just like, oh, okay, I try to read, and so you should know that exactly what is you are sending. So because of this, if you put it inside a struct, so you know exactly what is the size, it's much better. So you have exactly control over that. Over the data. Okay, so but by this example you understood that basically the order is just the same as you would write, and another thing is that you can send the different type of data, but you should exactly know the border. Okay. And so let me also, okay, so this all was regarding to the pipe and also PO. So I give you some example for the DAP. Okay, so this is DAP. I try to open up a text file here. So as I told you, okay, the DAP is a descriptor, is just trying to duplicating a file descriptor, right? But not the strings. So I try to open up. If you remember that open function is used to opening up a file, and just it basically returns a file descriptor. And here this file descriptor, I'm going to duplicating the file descriptor. So we have DAP, and so I'm passing the old FD, and so I have the new FD. But because so these two descriptors, they are after this DAP function, they are identical. So if I try to write something to the old FD, or if I try to write something to the new FD, so they will be the same. Okay. So what's the file? Yes, there are two different lines. Yes. And then, so as you can see, so I write basically both of the sentences, but when I was writing, so one of them with another descriptor, another one with another. Okay, so with two different descriptors, but because of the DAP, they are identical, and so but here I said that okay, I said that dot function try to find the low order descriptor. Okay, try to search and then find the first empty and then work with that. So I'm going to give you one example regarding to this.
By default, 0, 1, and 2 are allocated. Or
Yes, allocated.
Standard
Oh, standard error.
Okay. So it's
But we can change.
So to get one of these three, you need deliberately close, for example, standard input.
If you are going to, for example, use with one of these three, so you need to close them. And then, for example, like this example. Like this example here. So this is as before, but I close one. Okay, and because I close one, because the 0 is already allocated, right?
use it.
And because 1, it is just it would be the first in this example. It would be the first descriptor that is empty. So I expect that after the application, so the new FD is just pointed to the first, to 1. Okay, and just here I'm just going to print out the new FD. Okay. Okay, so as you can see here, so we have 1, and so we have 1 because so we know and we already closed 1, and so this is the first low order descriptor, and so we use 1. And okay, so what about the dot 2? So this is the example for regarding to the dot 2, and so here, so I open up the text file, okay. But so we said that okay, 0, 1, 2 is already assigned, right? But 1 is indicating std out. Okay. So if I write some things, for example, if I print f, if I have a print f, so basically it is just writing to the std out. Okay. But if I close std out, and if I try to print, so there is no out. Okay. But if I try to close the std out, and I just use it for another descriptor that is already exists. So if I write something to 1, is the same as I'm writing to the descriptor. For example, here for dot 2, I'm saying that okay. So as a new one, this is 1. If it's open, try to close it first, and then after that, writing to 1 is the same as writing to fd. Okay, so this is the dot 2, right? So we said that okay, dot 2 is just like making the new fd and old fd identical. So okay, here, so I expect that printf here. So because printf is a normal stdio, okay? It is a printout on the screen. But after this dot 2, when I print out some things, I expect that my output is written to the text file here, stdout.txt. So the reason for that was, so the reason for the first one was that okay, so we didn't have the text file, and so there was error in the opening up the previous descriptor. Okay. Okay. Any question? Okay, so for today it was just this